Hi there. This video covers limiting reagents, also known as limiting reactants. The word reagent and reactant are used interchangeably. Traditionally, this is called limiting reagents. It begins with some vocab here, the first two being limiting reagent and excess reagent. Limiting reactant is, or limiting reagent, is the reactant that we run out of first. Once we run out of the limiting reagent, the reaction stops. You can't make any more product. That's why we call it limiting. It limits the amount of stuff we can make. Excess reagent is the reactant that we have extra of. So you have leftovers of the excess reagent. Theoretical yield is basically the amount of product you can make. Actual yield, percentage yield, we'll come back to that a little bit later when we start calculating percentage yield. Here's a little limiting reagent scenario. You have a recipe of for turkey and cheese sandwiches. You work at some restaurant, you're making turkey and cheese sandwiches. The recipe is 2 pieces of bread, 3 slices of cheese, and 5 pieces of turkey. So that's a recipe, and the supplies or the ingredients you have 70 pieces of bread, 84 slices of cheese, and 155 pieces of turkey. First question is, how many sandwiches can you make? Well, what we do is we look at each ingredient. So bread, we have 70 pieces, and each sandwich requires 2 pieces of bread. So we can make 35 sandwiches if we just look at bread. If we look at cheese, we have 84 pieces of cheese, and for each sandwich, we need 3 slices of cheese. So 84 divided by 3 is 28. And turkey, got 155 pieces of turkey. For each sandwich, we need 5 pieces of turkey. So if we just look at turkey, we can make 31 sandwiches. So bread we can make 35, cheese we can make 28, turkey we can make 31. The thing is, to make a complete sandwich, we need all 3 of them. So 28 is actually the number of sandwiches that we can make. Because once we run out of cheese, we can't make turkey and cheese sandwiches anymore. So that's how many sandwiches we can make. The limiting reagent, or the thing we're going to run out of first, is the cheese. The excess reagents are the other things. We're going to have extra bread. We're going to have extra turkey. So those are our excess reagents. Last question here is, how much of each excess reagent will you have? This is a little tricky because we're talking about sandwiches here. 35 to 28, that is a 7 sandwich difference. But since each sandwich has 2 pieces of bread, so that's 7 sandwiches worth of bread, is 7 times 2 is 14. So we're going to have 14 pieces of bread left over. The 28 to 31 difference, that's 3. So 3 sandwiches worth of turkey is going to be left over. And since there's 5 pieces of turkey for each sandwich, that would be 15. So 14 slices of bread left and 15 slices of turkey left. So that's kind of what we're going to be doing here, but in a chemistry sense. We're going to use, instead of a recipe, like 2 pieces of bread, 3 slices of cheese, 5 pieces of turkey makes 1 sandwich, we're going to use a balanced equation. And we're going to find out which chemical we run out of first and which chemical is going to have extra, and then figure out how much extra of that chemical there is, and find out how many sandwiches we can make, or how many products, how many grams or moles of a certain chemical we can make. So these are the steps we're going to work through. The first part is going to be identify the limiting reagent. That's always the first step. You got to figure out what you're going to run out of first, because just like with our little turkey and cheese sandwich analogy, the cheese, since we ran out of the cheese first, that determines how many sandwiches we can make. So the cheese kind of controlled everything. It didn't matter how much extra bread or turkey we had to the number of sandwiches we could make, because once we ran out of cheese, we couldn't make any more sandwiches. So the limiting reagent kind of controls everything. So to determine the limiting reagent, first you want a balanced equation. You convert one of the reactants into the other, and then you look and compare your calculated number to what's given to you in the question. And you ask yourself, do I have enough? We'll come back to that. It'll make more sense once we do an example. Determine the theoretical yield. Again, since the limiting reagent controls everything, that becomes your starting number for any other calculations. You're going to turn your limiting reagent into product. And lastly, determine the amount of excess reagent. You take the excess reagent, you figure out how much you need, you subtract that from what you have, and that gives you your leftovers. Again, that'll make a little more sense once we get into this example. There is an example here in the notes. I'm not going to go over this, but this is a good resource. If you get stuck, go back to this, read it over. I go through all the steps. I explain what I do in each step and why I do it and what it means. So that should be a good resource if you get stuck on, say, one of the practice quizzes or something. So I'm going to do this example right here. 2.44 moles of hydrogen are reacted with 1.53 moles of oxygen according to the following equation. 2H2 plus O2 makes 2H2O. So the first thing is identify the limiting reagent. If you look back in your notes, we need a balanced equation, which we have. And we need to take one of the reactants, doesn't matter which one, and change it into the other reactant. And I'll do both. You don't have to do both technically. A lot of people get in the habit of doing both because it can actually save you a little bit of work on part C once you get to that. And it can help you kind of see what's going on here. But one thing I want to point out, we're using stoichiometry here. That's the mathematical skill we're going to use to determine the limiting reagent, theoretical yield, and all that stuff. So we're using stoichiometry as a tool here. And if you think back to the stoichiometry questions, it kind of looked like this. You had a balanced equation, you had a number. The difference here, though, is we have two starting numbers. We got 1.53 moles of oxygen and 2.44 moles of hydrogen. You got two starting numbers. Now, like I said, it doesn't really matter which one you start with. So I think I'll start with 2.44. 2.44 moles of hydrogen, which is H2. It's diatomic, so you put that 2 there. Times blank line moles H2 on the bottom. All that should happen automatically. And again, what we're doing is we're changing one reactant, in this case H2, into the other reactant, O2. So I'm going from H2 to O2. So that's what goes on top, mole O2. Mole over mole, I get my numbers from my balance equation. There's a 2 in front of H2 here, so there's going to be a 2 here. There's a 1 in front of O2 there, so I put a 1. And I do that math. 2.44 divided by 2 is 1.22. Moles H2 cancels, moles H2, so we're left with moles O2. Now, we did stoic, we got a number, but we're not done yet. So Stoichiometry is just a mathematical skill. We need to look at this number and figure out what does that number mean. And I think the key to figuring this out is when you calculate this number here, what you're doing is you're figuring out how much O2 you need. And you're comparing that to how much O2 you're given. I always call these starting numbers, like the 2.44 is a starting number. Another term for that, and you probably heard it in math class or other science classes, is given. So you find your given in the question. Well, if I give you something, you have it. So you have 1.3 moles of oxygen. You need 1.22 moles of oxygen. Well, what does that tell us? Well, we need less than what we have, so we have extra. So what that means is the O2 is the excess reagent. We're going to have extra oxygen. Again, you calculate what you need. So we need 1.22 moles of O2. Well, we have 1.53 moles of O2 of oxygen. So we have extra. Well, if O2 is the excess reagent, by definition, H2, the other reactant, will be your limiting reagent. It can happen where you could run out of both chemicals at the exact same time, and I think there might be a book question that does that, but I won't give you any on the assignment, the practice quiz, or the test that runs out of both reagents at the same time, because then they'd both be limiting reagents. For our purposes, if you figure out one is excess, the other is limiting, or vice versa. If you figure out one is limiting, you know the other one's excess, even though that's not always true. So like I said, you could have started with either reactant. In this case, we decided to start with mole of H2, because again, we got two starting numbers here. You can start with either one. Well, I'm going to show you real quick in the next couple minutes that if I started with the other starting number, it doesn't matter. You'd end up with the same result. A different number, but you'd still figured out that O2 is excess, H2 is limiting. So I'm going to set that up real quick. I might pause it and set that up. So I set up the other math here, the other stoichiometry work here. Again, starting with O2, because I'm just proving to you that it doesn't matter which one you start with. You could start with 2.44 moles of hydrogen or 1.53 moles of oxygen. Either way, you end up with the same result. And you can see that here. 1.53 moles of O2, I set it up. It's basically a flip-flop of the last math that I did. And I get an answer of 3.06 moles of H2. Again, what we're calculating here and here is what we need. So if I look at this, it says, I just calculated the fact that I need 3.06 moles of H2. Well, if I look up here, my given, what I actually have, I only have 2.44 moles of hydrogen. So that means I don't have enough, which means I'm going to run out of it, which means hydrogen is limiting. Because by definition, limiting reagent is the one you run out of first. And if H2 is limiting, O2 is the excess reagent. So it doesn't matter which number you start with. Either way, you'll see that you get the same result. You'll figure out the correct limiting and correct excess. Part B and Part C will be in the next video. So that is it for this video.